let's have a really quick look at Newton's laws of motion. There are 3 of them, and we can demonstrate all 3 laws with these 3 objects. Firstly, the first law of motion. There you go. My water bottle is showing the first law of motion. But wait, we can do this. It is now, once again, showing the first law of motion. So Newton's first law says that an object will remain in constant motion unless acted on by an outside resultant force. Now, a lot of people say it will remain at rest or in constant motion. Well, this is constant motion because right now my water bottle is not moving, and if we wait 5, 4, 3, 2, 1, now it's still not moving. So this is constant motion, it's just constant zero motion. So at rest is constant motion. And now it's just rolling along the desk, but now it's still rolling along the desk. There was an object in motion, its inertia kept it an object in motion. Okay, so if something has more mass, it has more inertia, and it's harder to change the motion of something with more inertia. So it's easy to stop a skateboard rolling towards you, hard to stop a car rolling towards you. Anywho, that was the first law. Second law of motion, Newton's second law, is this. Now the first law said we needed a force to accelerate an object to change its motion. I had a force supplied by my fingers. So okay, now that we've got that resultant force, let's see what happens to the object now. The second law says that when that resultant force is applied, that object will accelerate in the direction of the force. So I hit this way and the pen moved that way, but also directly proportional to the size of the force. If I tap the pen a little bit, if I only supply a little bit of force, it doesn't accelerate very much. If I apply more force, it accelerates more. If I apply more force, it rocks off to the other side of the class. So the greater the force for a constant mass, the greater the acceleration. If I supplied the same amount of force to the water bottle as I did initially to the pen, just a small amount of force, the water bottle hardly moved at all. This is because it has a bigger mass. It's filled with water, it has a larger mass. So for the same force applied, bigger mass means it will have a smaller acceleration. But for the same mass, when I had 2 pens, bigger force, bigger acceleration. So that's F equals ma, Newton's second law of motion. Now, the third law says this. Ow! My fingertip. Gee, that really hurt. Okay, so it didn't really, but the idea is that when I apply a force onto the water bottle applies a force back onto my fingers. The same size force, the same amount of force, but in the opposite direction. So the third law is for every action force, there is an equal but opposite reaction force. That's why you may have noticed on movies when someone punches someone on the face, and then they go, ow, hurt my hand, quick, get me an ice pack. Yeah, that's because as they were punching the person on the chin, the person's chin was applying the same amount of force back into their hand. So if you don't know how to make a proper fist, you will hurt your fist when you punch something. So there we go, Newton's third law of motion, and that covers them all. There are only 3. Newton's 3 laws of motion. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.